evaluating limits algebraically. So let's go to this worksheet. Which is indeterminate at x equals 1. So remember, indeterminate specifically means you get 0 over 0, which means to do more work, you have to solve it, so it's indeterminate. If you get 0 over 1, or 0 over anything actually, that is just 0. And if you get something over 0, that's undefined. The one we're looking for is indeterminate. So all we're going to do is sub in 1 to all of these. So plug 1 into here, I get 2 over 0. So that is undefined, can't divide by 0. And here you plug 1 in, I get 0 over 3. That would just be 0. And to here, I get 0 over square root of 4 is 2. To my side, I get 0 over 0. So this one's indeterminate. Indeterminate. This one you plug in 1. In that case, I get 2, already not indeterminate, over square root of 4, 2 minus 2. So that's undefined. So only one is the third one. Okay, so let's evaluate limits. Let's evaluate limits algebraically. So remember, all we're gonna do is sub in 5. Sub in 5. If you get an answer, you're done. If you get 0 over 0, then you have more work to do. It's all about how to simplify. So you can factor, you can do lots of things. But the first thing always with limits is sub it in. So 5 squared minus 25 over 5 minus 5. 25 minus 25 over 0. 0 over 0. So indeterminate. So it means that now we have to do some work. So in this case, we're just going to factor the top. So that's x minus 5, x plus 5, over x minus 5. These cancel out. So left with the limit. Now notice again, I have not subbed in. I haven't subbed in my value yet, so I have to rewrite the limit of x plus 5. Plug it in, and you get 10. Next one, same idea. First thing we do is sub it in, see if it works, because sometimes it just works. 2 times 7 minus 14 over 5 times 7 minus 35, but this is not going to work. So we get 0 over 0, so indeterminate. Again, that just means we have more work to do. So we got in this case, we're going to factor it again. So limit st goes to 7. On the top here, they both have a 2. And on the bottom here, they both have a 5. These cancel out, and we get the limit st goes to 7 of 2 over 5. Well, that's a constant, so you just get the constant. And there we go. And we go to the next ones. So again, let's sub it in. I'm going to get 64. I'm going to go a little faster now. So 8 squared is 64. 64 minus 64 is 0 over 0. So it's indeterminate. So now let's fix it. I'm going to factor. The limit as x approaches 8 is x minus 8, x plus 8, all over x minus 8. These cancel. So I have the limit as x approaches 8 of x plus 8. Sub it in, and you get 16. The next one. So look at the next one. Sub in 8. Try it first. And look what happens. On top I get 64 minus 64, which is 0. But on the bottom I get negative 1. Well, that's just 0. Remember, 0 on top is a 0. So that one wasn't indeterminate. It actually got a value for that one. Next one. Try subbing it in. So I get 2 squared minus 3 times 2 plus 2 over 2 minus 2. So I get 4 minus 6 plus 2 over 2 over 0. So I do get 0 over 0 in that case. So that means I have to factor it. So I need two things to multiply to get 2, but add to get negative 3. So that sounds like x minus 2, x minus 1. X minus 2. These cancel, and we get a limit as x approaches 2. Remember, you have to keep on writing until you sub it in. And now I can sub it in. I just get 2 minus 1, which is 1. Next one. Okay, so first let's try. 2 cubed minus 4 times 2 over 2 minus 2. This is going to be 8 minus 8 over 0. So it's going to be 0 over 0. Indeterminate. So, factor. On the top here, they both have an x in common. X squared minus 4 over x minus 2. Got to factor some more. And again, notice I have not subbed it in, so I'm still writing the limit. This is a difference of 2 squares. X minus 2, x plus 2. Over x minus 2. These reduce, so now I have the limit as x approaches 2 of x times x plus 2. Now I can sub this guy in, and I get 2 times 2 plus 2, or just 8. Next one. A little bit of a change this time. So on this one, same thing. If you plug in 0 first, you're going to get 1 cubed minus 1, which is 0 over 0. So 0 over 0 is indeterminate. Now in this one, we can't really factor. So what we're going to do is we're going to expand this and see what happens. So the limit as h approaches 0, again, you have to keep on writing the limit until you actually sub it in. Let's expand 1 plus h times 1 plus h times 1 plus h minus 1 all over h. Now if you multiply this all together, remember it's all done group-wise, so you do like these two first. So 1 plus h times 1 plus h. That's going to get you 1 plus 2h plus h squared. Then you can multiply that by 1 plus h. If you do that correctly, you should get h cubed plus 3 h squared plus 3h plus 1. Make it a little nicer. This is a little messy. If you distribute this one correctly, you should get h cubed plus 3h squared plus 3h plus 1. So that is this part right here. Let's rewrite it. Limit as h approaches 0. And then this part is h cubed plus 3h squared plus 3h plus 1. And then we have minus 1. Remember the minus 1 is from there, which is from here, over h. And then stuff cancels out. Well, really only one thing. Plus 1 minus 1. So we get h, no, sorry, not h, limit as h approaches 0 of h cubed plus 3h squared plus 3h all over h. Now remember, the whole point of this is you just want to plug 0 in. But if I plug 0 in right now, I still get 0 over 0 because there's all h's. So factor. They all have h's on top. So you can factor out an h, and you get h squared plus 3h plus 3 all over h. These cancel out, and you get the limit as h approaches 0 of h squared plus 3h plus 3. And now you just plug in 0. So you get 0 squared plus 3 times 0 plus 3, which is just 3. And that's the answer. Next one. So we try plugging in 2. I might just plug it in real quick. I don't like the block. Let's look how much doing work. So 2, 2, 2. You would get 4 times 2 squared is 4. 4 times 3 is 12. Minus 8 minus 4. So that's going to be 0 on top. On the bottom here we get 2 squared is 4. You get 2 times 2 squared minus 8. This is 4. 4 times 2 is 8. 8 minus 8, so 0 over 0. So we get 0 over 0 again. Which means, let's factor. Okay. Indeterminate, we got to factor or something. So the limit as x approaches 2. The top here, the number of friends, I'm going to factor it this way. Hold reliable. 3x squared times negative 4. That gets me negative 12. Negative 12x squared. So I need two things to multiply to get negative 12. I had to get 4, so negative 6x and 2x. right? When I multiply these two, I get negative 12. So I need to get negative 4. So negative 6x and positive 2x. Now I'm going to sub this in for the middle term there. So it becomes this. Right, I sub that in for this guy. So we're plugging that in for the middle term. And now we just factor by grouping. I mean, again, you can factor the same way you want. This is the way I'm just showing you. Bring on the middle sign. Factor out of 2. And do that. I'm going to bring on the middle sign, which is the plus. Factor out the 2. X minus 2. These match. X minus 2. 3x plus 2. And on the bottom, they both have a 2 in common. And I can factor a little bit more. The limit as x approaches 2. With the difference of 2 squares, so I get x minus 2, 3x plus 2, 2, x minus 2, x plus 2. Right, so factor the top, factor the bottom, all the way to get to here. And now something cancels. We get the limit as x approaches 2 of 3x plus 2 over 2 times x plus 2. And now we could just sub in 2 see if it works. And I get 3 times 2 plus 2. Again, once I sub it in, I don't need to write limit anymore. So I get 6 plus 2 over 2 times 4. So 8 over 8, which is just 1. So that work, I get a 1. Okay, next one. So different type of problem. This one. This is the radical one. So there's a couple ways to do the radical one. I'll show both ways. So I guess first, always sub in 16 see if it works. Now, if I sub in 16 here, I'm going to get 4 minus 4, which is 0. And then 16 minus 16, which is 0. So 0 is 0, so it is indeterminate. I'm going to save a little space because I might need it here. So the first way we want to think about solving this is by multiplying by the conjugate. So if we multiply by the conjugate, that means we're going to take the number up, the numerator here, because that's radical x minus 4, and we'll multiply by the conjugate of that, which would be radical x plus 4. And then where you multiply the numerator by, you multiply the denominator by also. Right, so where you multiply the top by, you multiply the bottom by. That's the conjugate. Now the conjugate is if you have a minus b, you multiply that by a plus b. Or if you have a plus b, you multiply by a minus b. And what's so great about that, when you multiply, you get a squared minus b squared, a difference of 2 squares. So that's the whole point of the conjugate. So if I do that, we're going to get a limit as x approaches 16. Multiply the top. Again, it's a difference of 2 squares, so we're just going to get the first term squared minus the second term squared, which would be that squared is x, minus 4 squared, which is 16. On the bottom here, you want to always, when you multiply the conjugate, don't try to simplify the bottom. Don't be a hero. Just leave it the way it is. So it's x minus 16, rad x plus 4. And look what happens. The x minus 16's cancel. Now keep in mind when something cancels from the top, there's nothing else there. There's always a 1. When you cancel something, it's a 1. So you get the limit as x approaches 16 of 1 over radical x plus 4. Right, now I can plug in, now we get the sub in the 16, and we get 1 over rad 16 plus 4. It's going to be 1 over 4 plus 4, or 1 over 8. So that's the first way you could do it. Alternate way of doing it, we'll do it over here. Way 2. So here's the limit as x approaches 16 of rad x minus 4 over x minus 16. So the way of doing it is by factoring. And we can factor the bottom here. So when you factor, it's a difference of 2 squared, it's a minus. What it would be is this. You know, the limit as x approaches 16. You factor the bottom. Well, think about the difference of 2 squares. It's the square root of this, which is 4. And then the square root of this. Well, that's 1. So how do you square root it? You divide it by 2. So it's x to the 1/2 or radical x. And radical x plus 4. If you multiply these two things together, you're going to get x minus 16. So you can always factor stuff. If I would have gave you x minus 7, you can't factor that. Yes, you can actually. It's not going to be pretty. It'd be rad x minus rad 7 and rad x minus plus rad 7. This still gets the job done, just not pretty. So you could factor, so you could factor anything. Top we're going to leave alone. I was supposed to erase. Top we're going to leave alone. Radical x minus 4. And look what happens. These cancel. We're left with the limit as x approaches 16 of 1, because the intended cancel is still 1, or rad x plus 4. Sub in 16, and you get 1/8 again. So two ways to do it. You can either factor if you're pro by factoring, or you can multiply by the conjugate. Okay, next one. Limit as h approaches 0 of 1/3 plus h minus 1/3 all over h. So now this one, there's no real factoring. There's no, you don't want to do a conjugate on this. It's a radical. There's fractions. So what we're going to do instead is we're going to try to combine these two. We need common denominators. So let's rewrite this. This is for a little more space. Alright, so I have 1/3 plus h minus 1/3. I'm giving a little space, so I'm going to show you what we're going to do. So if we're trying to add these two fractions up, well, you need a common denominator. The common denominator between 1/3 and 1/3 plus h is just going to be 3 plus h times 3. So like this side is missing the 3 by itself. So multiply by 3/3. This side is missing 3 plus h by itself. So multiply by 3 plus h over 3 plus h. And now we have the limit as h approaches 0. And we have 3/3 times 3 plus h minus 3 plus h over 3 times 3 plus h all over h. Now the most important thing I did here was this right here, parentheses. By far the most common mistake people make is that they put the parentheses here, and all they do is subtract 3 but not the h. You're subtracting both of them. And keep in mind, this is a divide sign, so I was going to rewrite it. The limit as h approaches 0. Let's combine the tops. This is going to be distribute 3 minus 3 minus h all over 3 times 3 plus h. Right, just combine the tops. Same denominator, combine the numerators. Then we're dividing by h. Right, it's divide sign by h. Let's simplify and rewrite. These cancel. So we're going to limit as h approaches 0. There's only a negative h on top. On the bottom we have 3 times 3 plus h. And then dividing by h, the same thing as multiplying by the reciprocal. So 1/h. And look, these cancel, and we're left with the limit as h approaches 0 of negative 1/3 times 3 plus h. Once you get down here, plug in the 0. So I get negative 1/3 times 3 plus 0. Negative 1/3 times 3. Negative 1/9 is my answer. Moving on to this one. Now remember, before we do anything, before we go multiply the conjugate, try h equals 0. See what happens. So I plug in 0 here. I get radical 2 plus 0 minus 2 over 0. I get rad 2 minus 2 over 0. That's not 0 over 0, that's not indeterminate, that's just undefined. Right, if we look at the graph of that guy, it's going to look kind of like this. The limit's not going to exist at 0. It's remember, anytime you get undefined, that essentially means you have vertical asymptote. So, anytime you get zero denominator, and not 0 on top, it's not indeterminate. It's undefined with 0 on the bottom, which means you have vertical asymptote, which means the limit does not exist. Now, if they say from one side, like plus or minus, then you have to tell if it's positive. Like in this case, one side's negative infinity, one side's positive infinity. But generic, the letter does not exist. Sometimes it might be, if you get something that's like that, and you have a graph that they both go the same direction, it can still be considered infinity. That's more descriptive. Does not exist is accurate, but sometimes, like if it's on the multiple choice in the AP exam, they want you to be a little more descriptive, so it won't have does not exist, so just have positive or negative infinity, and then you know which one to pick. If you're not sure, graph it. Sometimes we'll just have does not exist and you're fine. So technically a limit has to be a number. Infinity is not considered a number, so it does not exist. But if the AP exam wants to be a little bit more descriptive, what type of does not exist is it? Is it straight out does not exist? Or is it like positive infinity or negative infinity? Then you'll see that in the multiple choice. Anyway, the next one, limit as x approaches cosine of 0. So if I plugged in cosine of 0 first to see what it is, because that's always our first step. Cotan of 0, that's 1 over tan of 0. Tan of 0 is 0, so this is 1 over 0. Cosecant of 0, cosecant of 0 is it's 1 over sine of 0. Sine of 0 is also 0, so this is 1 over 0. So I actually do get 0 over 0. So it's indeterminate. So how do I solve this? Well, how goes your trig? So we're going to the limit as x approaches 0. Cotan is cosine over sine. Sine over cosine is tan, so cotan is cosine over sine. Cosecant is 1 over sine. This is a divide sign, so rewrite it. It's limit as x approaches 0 of cosine x over sine of x divided by 1 over sine of x. And we know that by now. That means cosine x over sine of x times reciprocal. Sines cancel, so this is the same limit as x approaches 0 of cosine of x. Plug in 0. Cosine of 0 is 1. Alright, so we go right here. That's the point 1, 0. Sine e, cosine is the x value, so 1. See? Trig identities, they do come in handy in math. Next one, limit as x approaches 0 of e to the x minus e to the x, e squared x over 1 over e to the x. So as always, first thing I do is plug in 0, see what works. E to the 0 minus e to the 2 times 0, all over 1 minus e to the 0. This is going to be 1 minus 1 over 1 minus 1. So it is indeterminate, so we do have to work on it. Do the work on it. So the easiest thing to do here is factor. The limit as x approaches 0. On top, let me rewrite it. Because right now, like, how do I factor in e out? All that is this. It's e to the x minus e to the x squared. Remember when you multiply, the way you do a power to power is multiply? So this is the same thing as saying 2x. That's all it is. On the bottom we have 1 minus e to the x. So I can factor out an e to the x on the top. And then you're left with, well, you pull the e to the x out, that's a 1. Minus, there's still one more e to the x, so you took 1 out, but there's still 1 left. So e to the x all over 1 minus e to the x. And look, these cancel. Get a 1 on top, so we have a limit x approaches 0 of e to the x. Then we sub in 1, e to the 0, which is 1. Next one. Right, this one looks scarier than it is. Remember, all we do is limit is sub it in. So sub in is 0. What do I sub it in for? There's only one variable. It's the x. A is a constant. We just don't know what number it is. So plug in for the x. And you get 2a plus 0, or just 2a. Next one, same idea, but this time notice what the variable is. It's an h. So we're plugging in for the h. So 4a negative 2 plus 7a. Which gets me negative 8a plus 7a, or negative a. Last problem, same thing. Now this time the variable is t. So we're going to sub this in for all the t's we see. So 4 times negative 1 minus 2a times negative 1 plus 3a. I get negative 4 plus 2a plus 3a. So I get 5a minus 4. There we go. That's a worksheet.